9.2 Ellipses. What we should learn. How to write equations of ellipses in standard form. How to use properties of ellipses to model and solve real life problems. So this is an ellipse. Your first thought might be this looks sort of like a circle. And that's right. What's one big difference? In a circle, the radius is the same distance all the way around. No matter if you go across, up, down, left, right, it's always going to be 5. In an ellipse, one side is bigger than the other side. Giving an ellipse like this, the distance from here to here could be 6, and the distance from here to here could be 3. It won't be even, which gives it its oval shape. That's what makes it an ellipse. This image here shows how we create an ellipse. We get 2 fixed points known as foci, and we fix their distances away from them. We're going to keep that constant all the way throughout, and you'll make the ellipse. It looks something like this. See there? In this image, the green purple line always add up to be the exact same number. That's how you create an ellipse. Let's talk about some vocab of an ellipse. So the center, just like in a circle, is called the center, in the middle of the ellipse. And then the long side, we call it the major axis. This would be the major axis. And then where it hits the ellipse, we call those vertices. That's our vertex. So there and there. And then the minor side, let's just say the smaller side, that's called a minor axis. And then where it hits the ellipse, we call those co-vertices. With that in mind, let's move on to a more formal idea. Here just shows you again how to create an ellipse, and then here's the mathematics behind the foci, and we'll talk about that a little more in a second. This is a standard equation of an ellipse. If you look here, you see 2 very similar equations. You have x minus h squared plus y minus k squared. In that case, just like in a circle, our center inside opposite is going to be h and k. So put a center here, and that's going to be our hk. You might notice the difference between these 2 equations. It's where the a squared is. It's underneath the x squared in this one, and it's underneath the y squared in this one. That's because the a is the major axis. When the a is underneath the x squared, that's letting us know that it's going to be a horizontal graph. It's going to look something to this effect. And that's because our a is the distance from the vertex to our center. The b is going to be the distance from our center to our co-vertices. The distance from our center to our vertex is a, the distance from our center to our co-vertices is b. And then when we talk about foci, our foci is how we create our ellipse. 2 fixed points here. Distance from our center to those points is c. That's how we have this equation for a foci. And that's all the major parts of an ellipse. You have your distance from your vertex, which is a, the longer side. You have distance to your co-vertex, which is b, the shorter side. And then your foci, the distance from your center to your foci, is your c. And that's the basis of an ellipse. And it works the same for your bigger numbers beneath the y. If a squared is equal to y, it means our major axis is vertical, and our ellipse is going to be vertical. Same concept. Our center is going to be right in the middle, our h and k. The distance from your center to your vertex, the longer side, that will be your a. The distance from your center to the co-vertex, the shorter side, that will be your b. Our foci, the 2 fixed points we use to create the ellipse, the distance from your center to one of those is your c. And that's how we create ellipses. Now, this is a standard form we use most of the time. When we want to find the foci, we have a special foci formula for it. C squared equals a squared minus b squared. It has to do from the triangles we looked at earlier. This is the same thing down here. You notice when your a squared, the bigger number, is underneath your x, it's going to be horizontally. That means the longer side is horizontal, your x. When your a, which is the longer side, is underneath your y, then it's going to be a vertical graph. Is that all that? Let's do an example. Example 1. Find the standard equation of an ellipse. Given is find the standard form of an equation of an ellipse having foci at 0, 1 and at 4, 1 and a major axis length of 6. So we know the long side of our ellipse is 6. And with that, we should be able to find the rest. First, let's write down our equation. The standard form of an ellipse is x minus h squared plus y minus k squared over. I do want to figure out if my a squared is underneath my x or my y. Remember, a squared is the bigger one. But look at the picture here. Our major axis is this length here, the horizontal length, which means our a squared should be underneath the x because it's longer horizontally. And x is horizontal. Makes my b squared is my y. It's now all equal 1. Now, normally I like to draw a picture, but in this case, they already gave us a picture and they gave us everything we need. I would want to find the center. Center is h and k. Well, they gave it to us right there. 2, 1. There's my h and there's my k. They didn't need to give it to us. We can find it pretty easily. If you have your foci, which we do, it's always going to be halfway between your foci. It's always going to be halfway between your vertices and halfway between your co-vertices. The center is pretty easy to find. It's in the center. Next, I want to find my a and my b. They already told us our major axis length is 6. This from here to here is 6. That means our a is going to be 3 because it's half the length. It's from the center to the edge. Our a is going to be 3. Our b, they gave us a b. Our b is the length from our center to our co-vertices. They tell us right there, radical 5. So this is going to be radical 5 squared. And we are pretty much done. Simplify this. We're going to get x minus 2 squared over 3 squared, which is 9, plus y minus 1 squared over radical 5 squared. Those two cancel out, get 5. Or if you want to think about it, you get square root of 25, which is also just 5, equals 1. And there we go. That's the standard equation of this ellipse right here. Let's do another one. Example 2, sketching an ellipse. Sketch the ellipse given by 4x squared plus y squared equals 36 and identify the center and the vertices. When we sketch an ellipse, we also want to put it in standard form. It's easy to find all the things we need to find. So given our two standard form equations, if you notice, they always equal 1, which means we want to make this guy equal 1. Easiest way to do that, we're just going to divide everything by 36 to make this side equal to 1. Divide by 36. So it looks like the standard form. Over here, we have 4 over 36. We could reduce that. We could divide them both by 4. So we get x squared over 9 plus y squared over 36. And 36 divided by 36 is just going to be 1. So there's my standard form of an ellipse. And we're going to use this to graph. Here's my xy chart. I should label my axes. And the first thing we always want to find when you graph is the center. My center here looks like 0, 0. There's no h and k, 0, 0. Right there. Next, let's find our a and our b. In this problem, the number underneath the y squared is the bigger number, which makes this our a squared. Now make this guy our b squared. When we graph it, we just want to graph the a. I know a squared equals 36. Square root both sides, a equals 6. That's how much we're going to travel on our y, because it's underneath the y squared. 6 up, right there. And we're going to go 6 down. This point here will be 0, 6. This point here will be 0, negative 6. Same idea for our b. B squared equals 9. Square root it. B equals 3. Well, plus or minus 3. We're going to go 3 in each direction on the x, because it's underneath the x value. 1, 2, 3. That'll be 3, 0. And then 1, 2, 3. Negative 3, 0. And then we can graph it. We're just going to connect all the points. And there is my ellipse. Now, they didn't ask for it, but I'm going to add in the foci. If I want to find the foci, the point of the foci, so the equation for foci is c squared equals a squared minus b squared. Basically, the bigger one minus the smaller one. We already have a squared and b squared. A squared is 36, and b squared is 9. We're going to get c squared equals 27, square root both sides. And c is in the square root of 27, also known as 3 square root of 3. Or we could round it to 5.1-ish. The reason I wanted to do the foci is how do we graph the foci? The foci is always on the major axis. It has to go on the major axis. I'm going to go up and down my foci on this one. From our center, we're going to go up 5.1, 0, 5.1, and we're going to go down 5.1, negative 5.1. And there's our graph. I have my co-vertices at 3 and negative 3. I have my vertices at 6 and negative 6. And I have my foci at 5.1 and negative 5.1. It's a nice graph. Next one, we're going to graph the list. We're going to kick it up a notch. In this case, if you remember when we did circles, we had to use complete the square to put this in the proper form. So step 1 is rearrange. So you want to put all the x's together and all the y's together. I'm going to have x squared plus 6x. I'm going to put space and we're going to do the y's plus 4y squared minus 8y. And I do like to move over the 9, minus 9 from both sides. Give myself a little space equals negative 9. That's the first part. We want to rearrange. Step 2, we're going to complete the square. We want to add negative b over 2 squared to both sides. Let's start with the x. I'm going to divide it by 2 and I'm going to square it. 6 divided by 2 is 3. 3 squared is 9. We're going to add that to both sides. Plus 9 here, plus 9 here. Let's do the same thing for our y. To complete the square on our y is going to be a little tougher because the coefficient on y squared is not 1. You need it to be 1 to complete the square. We're going to have to factor out of 4. Factor out of 4 from all of them. We're going to divide by 4. I get y squared minus 2y. I like myself a little space. Now let's complete the square. Same rule applies. Get the middle term, negative 2 and divided by 2. And square it, so I get negative 1 squared, which is positive 1. Anytime you square negative, it becomes positive. We're going to add 1 to both sides. Little caveat. We're going to add 1 here, but that 1 is going to multiply by the 4. We're actually adding 4 to this side. Plus 4 because I came from the 1 times 4. We added 1 here. It gets multiplied by the coefficient outside, which is 4. We have to add 4 to this side. Step 3, we're going to simplify and factor. That's how you complete the square. Let's factor this left side first. The trick to factoring it, if you complete the square, it's always going to be the middle term divided by 2. So this is going to be x, then 6 divided by 2 is 3. That's why we complete the square, to make the factoring so easy. Same thing happens with our y's. This is easy to factor. It's always a middle term divided by 2. So that's going to be y minus 1, negative 2 divided by 2. And don't forget the coefficient to the 4 in front. Very, very important. And we're going to set that equal to this side. Negative 9 plus 4. The 9's cancel. You just get 4. And we're almost done. 4, you got to put in standard form. Standard form of ellipse is when it equals 1. We're going to divide everything by 4. That'll give us x plus 3 squared over 4 plus, these cancel, got the squared, y minus 1 squared over 1 equals 1. That's our standard equation. It said they want us to graph this ellipse. Putting in standard form makes it easy to graph it, but we do have to graph it still. So I want to graph this. First, let's find our center. Inside opposites, -3 and 1. Our A is a bigger one. In this case, our A is going to be underneath the x squared, which means it's going to be a horizontal graph. We know a squared equals 4, which makes a equal 2. Underneath the y is our b in this case. B squared equals 1, square root, b equals 1. Now we have everything we need. Let's graph it. Our center is -3, 1. We'll go left 3 and up 1. That's our center. Our A is 2. The important part about this is our A is on the x. So horizontally, we're going to go 2. 2 to our right and 2 to the left. Right there. And our B, our co-vertices underneath the y is 1. Since 1 is underneath our y, we're going to go up and down 1 on the y. And I get a graph that looks like this. That's your ellipse. Next one, example 4, analyzing an ellipse. Find the center, vertices, and foci of the ellipse. Similar problem as last time, but now we want to also do the foci. And I guess we don't have to graph it. I'm going to graph it anyway, because I think graphing it makes it easier to find the rest. We'll start the same way. Step 1, rearrange all the x's and the y's. We're going to have 4x squared minus 8x, and leave a little bit of space, and we're going to do our y's. Plus y squared plus 4y. Then we're going to move over our constant equals 8. Next, we're going to compute the square. And this time, the x has a problem. I can't compute the square yet because there's a 4 in front of the x squared. We have to factor that out. The 4 on the outside, we're going to get x squared minus 2x. Our y's don't change. Next, let's compute the square. We're going to get the middle term divided by 2 and square it. We're going to get -1 squared, which is 1. Add it to this side. Remember, on this side, we're going to be adding 4, because that 1 gets multiplied by 4. So just same thing for the y squared. The middle term divided by 2, and then square it. Complete the square. We're adding 4 to this side and 4 to this side. Next, let's simplify and factor. The left side, the trick is it's always a middle term divided by 2. This is going to be x minus 1. This is why we can move the square to make that easy. And don't forget the 4 on the outside. The next one, always middle term divided by 2. Y plus 2 squared equals, we're going to add all this up, and we're going to get 16. We're almost in standard form. We have to make it equal 1, though. We're going to divide both sides by 16. That gets me x minus 1 squared over 4 plus y plus 2 squared over 16 equals 1. So there's my standard equation. Now the question was, let's find the vertices, the co-vertices, and the foci. I always find it easier to graph it to find everything I need. Here's our graph. Let's first do our center. Our center is going to be inside opposite. Makes it 1, -2. Right there is my center. So center's down. Next, we got to find our vertices and our co-vertices. Vertices are always on the major axis. A squared is always our bigger number. In this problem, a squared is underneath our y. So this guy's going to be our a squared. So it's going to be a vertical graph up and down. And this is going to be our b squared. And generally, I don't overthink it. A squared equals 16. Square root it. A equals 4. Since that was underneath our y squared, we're going to move that much on our y. I'm going to go up 4 and down 4. Starting at our center, 1, -2. We're going to go up 4 to here, 1, 2. And we're going to go down 4. 1, 2, 3, 4 to right here, which is 1, -6. Those are vertices. Let's find our co-vertices. Same concept. We know b squared equals 4. B equals 2. And in this problem, our 4 was underneath our x. We're going to go 2 in each direction. From our center, we're going to go 2 each direction. Starting at 1, -2, we're going to go 2 to the right. Give us 3, -2. And we're going to go 2 to the left from our center. That's going to be at -1, -2. And there is our ellipse. Co-vertices, -1, -2, 3, -2. The last thing I got to find is the foci. We do have a formula for the foci. It is c squared equals a squared minus b squared. The bigger one minus the smaller one. In this case, c squared is equal to 16 minus 4. C squared equals 12. Square root of that. And we get c equals plus and minus radical 12. Or, if we simplify, 2 radical 3. Now, that's not our answer for the foci. It's going to be a point. We have to go that direction, in the same direction as our vertices. Because remember, it's on the major axis, which is the longer one. From our center, we're going to go up 2 rad 3, and we're going to go down 2 rad 3. Easiest way to do that is don't overthink it. Don't overthink it. All we're going to do is add that to the y value. I have a foci around here somewhere. That's going to be 1 and -2 plus 2 rad 3. We'll have a foci down here somewhere, and that's the opposite way. 1 and -2 minus 2 radical 3. You can also round it and use your calculator and then add up decimals, but this way gets you the exact answer. Whatever radical we get, add it to either the x value or the y value, whichever one we want from the center. We're just going to add our foci distance to our center. And we also have 1, -2 plus 2 rad 3. And that's our lesson.